All right, everyone. Thank you so much for joining us today. We'll be discussing the hardest problems in crypto data. We've got a good selection of panelists here today that span all different parts of all different verticals of the data stack. So you get a lot of different perspectives on some of those hard problems around indexing, around bringing data on chain, around understanding and interpreting that data. So we'll dive in with to an awesome discussion around the challenges with standardization, trust, verification, how you actually bring data on chain, how you use that to influence and educate and understand. But before we jump into that, we'll just do a quick round of intros. So if everyone can just share a brief background on yourself and the organization you work for. We'll jump in with you, Jonathan, and move our way down the line.
All right. I'm Jonathan Skrzypek. I'm a director of data at Dune. Dune is the biggest on-chain data platform. We specialize in creating data, blockchain data at scale, and providing a platform for people to analyze and transform blockchain data. And our mission is to make crypto data accessible. And we help businesses navigate, the sea of the sea of complex blockchain data and trying to understand what is happening on chain.
Hello, I am Markus Levin. I'm one of the co-founders of XYO. XYO is a trustless oracle and the first DPIN collecting real-world data. It's more than 10 million nodes and validating and verifying it through our network and our new XYO Layer 1 blockchain. And we sell that data to Web2 and Web3 companies.
I'm Mike Cahill. I'm the CEO of Dora Labs and co-founder of the Pith Network. Pith provides data to companies that are building on-chain, as well as to people that are consuming data off-chain. We think of ourselves as a modern market data protocol. We basically created a new way for market data to be constructed outside of the traditional exchanges where a lot of the data is sold from. The way we've done that is by open sourcing it to participants that are big trading firms, and so we basically amass this network of data from trading firms and exchanges as well, and allows us to have this really scalable way to collect and aggregate and distribute data. We vision it as sort of the Spotify of market data. There's a single connection across all asset classes. There's currently around 3,000 different symbols. They're available at very, very high resolution and very low latencies, and they can be delivered on chain with cryptographic proofs, and also for people off chain.
My name is Brandon Kramer. I lead go-to-market and product marketing at the Graph Foundation. The Graph is essentially a suite of blockchain indexing tools. It gives you various kinds of data depending on your use case. We serve enterprise AI developers and ultimately make those solutions available to tap into via a data marketplace. The protocol that we run essentially allows consumers to connect to providers and tap into a decentralized network of data. And ultimately, our goal is to kind of make that data open, accessible, permissionless, and to be able to scale that in the future.
Awesome, thank you, gentlemen. And I think we were joking in the prep session that indexing is a solved problem, and I can feel Jonathan and Brandon both staring at me with a death stare here. But it's certainly not. But a lot of work has gone into it, and so I'm curious, when you think about one of those first big hard problems around standardization, I think each of us will have a different perspective on what the true standardization problem. Again, going back to the fact that we all live in different parts of the data stack. But Jonathan, maybe I'll kick it off with you again. When you think about the challenges around data standardization, whether it's how you present data to users from blockchain data that varies across different virtual machines, all the way down to how you guys internally think about and standardize that data. What are the biggest challenges when it comes to being a data indexer and thinking about standardization?
Yeah, I think there are really many dimensions here. Like one is like technically, differences between the different chains and different VMs. End of the day, a transaction and a transfer, for example, that goes from A to B, and people who want to analyze the data don't necessarily need or want to understand all the intricacies of the different VMs. They just want to understand like what transfer was involved and what was the reason behind that transfer. Something we've seen really early on that Dune focused a lot on was our DexTrace datasets, where end of the day, when you think about a decentralized exchange, a trade is a trade. Like you've got a direction, you're going to have a size, and you're going to have like a traditional finance, you call that a ticker. And none of that was standardized, and we integrated against 155 or so DEXs, and it's been really hard to find a data format that makes sense for all of them. And so that for allowing our users to just do the analysis that they need to, like answering what type of volume, what type of liquidity there is, and it's something that I think again, coming back to the DEX example, like in traditional finance, this has been like a solved problem for many years. But like for crypto, we kind of had to reinvent that standard. And DEX is just one vertical, but there's many of them. And for each vertical, you're gonna have to find, all the different intricacies and try to find something that is standard. And once you think you found something standard, you find the X protocol that actually doesn't fit in your standard, and then now you need to think about how do you make that evolve over time.
Yeah, so great answer. As Jonathan said, there are a lot of different layers to this. I think from the graph, I often think about it more kind of from the infrastructure perspective and the different tools that we have available to extract, transform, and load that data, and whether those standards are open, accessible, and scalable into the future. So at the kind of the semantic layer, we're providing access and kind of curating that for end users, obviously really, really important. But the other aspect of it is enabling providers to be able to compete in an open marketplace and ultimately having that continuity into the future. I guess from my perspective, I'm really I really find it quite appealing that enterprise, they have the Linux Foundation, things of this model, to kind of procure these open source products and ensure that they last into the future. To me, that's really important and has always been a core kind of value behind the graph. One thing that's quite interesting about that is in terms of trying to standardize that, there's obviously a tremendous amount of debate and back and forth and how to define those standards. One example is like T-Rex, for instance. We have ERC20, we know that's a robust standard, but as institutions come in, they need these standards to try to translate other kinds of token assets. And how do we do that? What kind of metadata do we need? How do we name those things? And it's not only important for maintaining that continuity, but also really important in the short term in terms of how we classify those things. Those disruptions that we see right now are going to last on the blockchain for a very long time. And rather than having to deal with them over and over, it'd be great to be able to sort them out as soon as we can. So.
Maybe to dive one more layer onto that, when you think about defining that standard and then communicating that standard outward, right? It's about, you may have your interpretation, but then if Dune or Blockworks maybe has their own, then now all of a sudden we have 3 standards. It's like there's a classic meme about this where it's like, oh, there's no standard, and it's like, oh, perfect, we need a standard, and then now there's 4 standards. And maybe an example of this is on Jonathan, you mentioned the DEX trading side of things earlier. Wash trading is inevitable in a permissionless environment. Anyone can spin up a new pool that has a 0% fee, and then trades can get routed through that. But depending on what type of filter you apply, you may or may not capture that, right? So a popular wash trading filter would be, okay, we'll just look at the value of the liquidity in that pool. Generally, the spam or just nonsense pools have a very low value of TVL or deposits in that pool. So we can just go ahead and completely omit that. Well, if in an attempt to spoof some of these metrics, we've seen actually large deposits of TVL come through in those 0% fees. They'll use flash loans to automatically pull large amounts of trade volume through this pool, and it ultimately costs like almost nothing because of how cheap transactions have gotten. So it's very interesting that depending on the filter you can use, you can actually end with a different result, and there's not a standardization around what types of filters are the best. So I think even as an industry on the low level, we have to have these standards like ERC20 or SPL tokens, and on the high level, we also need to align on like what is the best way to communicate this data outwards. And I'm curious with you, Mike, like when you think about bringing some standardization into the how value or even price in the sense of an oracle is represented on chain. I know the team at Duro Labs has been thinking about Rule 603 and maybe how that needs to change to accommodate sort of the modernization or new era of how we can represent price in a consistent and standardized way.
Yeah, when you get into the world of like regulated securities laws, it's very rigid, and so we've been working with the SEC, who is looking to reform this, and so it's no secret that Chair Atkins has been a vocal critic of Reg NMS for a long time. These rules, like many rules made by the SEC, are done with the best of intentions, right? But then they become these weird little nuances where there's people that figure out kind of workarounds, and then you just end up with this kind of clunky apparatus, which I'll sort of describe. So basically, for U.S. equities, they have Reg NMS, and it requires all of the NMS exchange, national market exchanges, contribute to something called the SIP. And then the retail brokers are required to show the SIP price to their clients. The intention of that is if you show something much wider, then the client gets a bad price. And so they call that the trade through. So you have to be able to offer something to trade through. That's great, especially if your markets used to be wide and now they're tight. But the problem is that limits the amount of competition that you can have within the US equity markets. So everyone knows that there's a lot of market makers that really want to get that order flow. And you've probably heard this term called payment for order flow. And it's probably the worst possible name for what actually is happening. It's just, I want to trade at that at a tighter price than what the law requires me to trade at. So this Reg NMS means that I have to show the client this spread, but Citadel and Jump and Jane Street all actually want to show something a little bit tighter, so they have to get a rebate from, or they're going to pay a rebate to the broker to be able to trade there. This is super inefficient, right? And we don't actually really need that anymore because you have these competitive markets. And so there's all sorts of gaps that are now being exposed with this, this architecture, because there's overnight trading that's not included in this SIP or in Reg NMS, and now there's even weekend trading. So where we've been working with the SEC is, hey, we got to fill these gaps because, first off, on-chain trading doesn't fit into the NMS structure. Certainly not today. Maybe at some point in the future it could. Overnight trading doesn't fit there. You already have that gap, and now weekend trading, isn't going to fit there. So you're going to have to come up with something that you can have to show your retail brokers for this display rule, this 603 display rule, and you can't use this SIP. So that's where we said you should be able to use something that aggregates all of this data together. That's what we do. That's what we've been building for a really long time. Historically, it's been a one-way street from if we wanted to get the price of Tesla on chain, we would go look at the off-chain world because that's where 100% of the volume was. This last 3 months, we've seen a very dynamic market structure change, notably in oil, where now about 1% of the daily oil market trades on the HIP-3 markets, on like Trade XYZ or Dream Cash. So now you have to take that into effect. And so that's something that we do. We start pulling in all the data from on-chain. We merge it together with data that we're getting from either ICE or COMEX styled oil contracts and creating a new feed. And so we're creating in real time this like 24-hour market structure that doesn't fit into any of these regulations that we'd seen before, but it does fit into the standard that we've put together for all asset classes. Because at the end of the day, all you really need is a price, some notion of what the bid ask is, and not too much else. There should be some volume indications there, but you can do that in pretty much all asset classes. Historically, it hasn't worked like that. Historically, it's been all the problems that were articulated for the on-chain stuff, you have those problems for off-chain as well. If you go to CME, it's different than if you go to the ICE. Some people use different types of protocol. On-chain, it's relatively simple. It's mostly WebSocket. So that's what we've done. We've sort of first principally put this together where we can just scalably answer the question, what's the price of this right now? And use that to be a very accurate price to be able to resolve the question of best execution or of a fair value. And we think that it's one of those things that's refreshingly simple.
Mike, that oil example you give is fascinating. I'm curious how that works on the weekends. Is it as simple as 99% of the price doesn't move, given that traditional markets are closed, and then that 1% is the fluctuation in the weekend price?
Oh no, because if you think about it, it's during the weekday. The hyperliquid plus there's a couple of others like I think Aster and Helix on Injective have a little bit. It's 1%, but on the weekend it's actually 100%. So it's a little bit more complicated to do it. So your biggest inputs are where did it close, what's the open interest and volume that's occurring right now, and where do I think it's going to potentially open. It becomes way easier to price as you get more open interest, right? Like that's obvious, right? So the harder thing to do is when you start bootstrapping new markets because they're so difficult to tie to another place. And that's what's been really cool about this oil market development. So Pith does provide for all of those protocols the data for them to be able to offer these real world assets on the kind of the 24/5 markets. And Trade XYZ actually created their own, and actually so did Dreamcash, their own sort of weekend market that they would use a couple of different inputs from like their mark and their open interest. Pith just introduced the Pith 24/7 oil market. And so we incorporate all of that information along with the information that's trading on the traditional markets to be able to make that move 24/7. You do need to put weights in place. We're evolving that over time, and it has all the problems you guys talked about, right? Like, so you have to make sure you're filtering out for wash trading. You have to make sure that you're changing if somebody looks out of line. You're also updating it for market hours versus non-market hours. So yeah, I think it's an evolving problem. And as I mentioned, it gets a little bit easier as volume increases. So it's like the most complex when you're introducing new assets. So we will be introducing new assets on a 24/7 index. We call it a single instrument index because it's just the pith price of something. And we'll do this for a lot more things. But it'll be most difficult for when we've got the first one that's going on a weekend. But then over time, it becomes a little bit easier because people start to trade it, and then you get the virtuous cycle.
That's fascinating. And maybe to round out the discussion around standardization, Markus, I'd love to hear from you. You spent the last 8 years bringing off-chain data on-chain, and you also have an interestingly diverse client base between both Web 2 and Web 3. So I'm curious, when it comes to the challenge of standardization, how has that impacted you when building out XYO?
Yeah, we have many different kinds of partners. Excuse me. Yeah, many different kinds of partners which want different data sets, right? Some of them buy raw data and they buy it in our standard, right? And then via APIs and other methods. But then there's people who want on-demand data. Let's say they say, okay, bring me all the ATMs in Manila, for example, and I want proof that they're really at a certain location and take a picture of that data, and there's basically no standard. So we have to agree on the standard with every deal, and that's extremely costly to begin with. So we're building basically a data place now where we're going to have our standards, and people who give us tasks just have certain parameters which they can choose the data to be standardized by. But the world is infinite, and data sets are infinite, right? You guys speak about on-chain data and standardization there, right? And it's limited in a way. But if you speak about the data of the world, it's difficult to standardize it as a whole.
And maybe that's a good segue to double down on you here. When maybe moving into trust, data quality, verification, right? The classic garbage in, garbage out problem. When you are bringing the on-chain location verification data on-chain, like what are the core challenges around data quality? And we were just having an interesting conversation right before we hopped on stage around the differences between accuracy and certainty. If you could also touch on that as well.
Yeah, so location data gets easily spoofed to hacked, right? You can download the GPS spoofing app and pretend that you are in Miami right now, but you're actually here in New York, right? It's a problem for most apps on your phone, but also for self-driving cars, smart cities, and the automated world of the future, right? Where everything runs on AI and robots and the machine economy. And to solve that, right, you need we solve it with connected devices, like where you have IoT devices doing these cryptographic handshakes to confirm each other's proximity to each other. As you have more devices, you get more certainty, and as those devices diverge and have different interactions, right, you get higher probabilities. And you can build relational maps and many things through it. And so you are able to get a very high proof point that something or someone is at a certain location, and so it's then when you have that data, you store that data, let's say in an IPFS database into the XYO layer 1 or anywhere else, right? You need provenance of that data. So it's you need to be able to prove that the data was true when it was generated and is still true when it ends up in your smart contract, for example. And to be able to do that, you need certain algorithms. In our case, we have something we call proof of origin, which tangles the data along the way to be able to prove where the data comes from and where it ends up in the end. And that's critical. If you think about AI, for example, right? AI hallucinates often, and it hallucinates. Often you don't know why, right? It's often a wrong data input, for example. And with blockchain and a deep-in data collection network, for example, you can prove where the data came from. So you have provenance, and then you have immutability through the blockchain component. and the accuracy versus certainty. So there's a great company in the space called GeoNet. They are doing something in location, and they do location accuracy. And they have these devices which you can buy, you can earn the GeoNet token as you put the devices up. And accuracy is one part of it, but the other big part is the certainty around data, right? Because, for example, you could put 10 sensors into a basement, right? And GPS proves them, right? And say, oh, they're at all these other locations, and the data, you would still get paid, right? And deep network are actually incentivized to show a lot of data on the chains, so they might not tell you, or they might not be incentivized to figure out which data is spoofed and which one is not. So data certainty is highly important.
Yeah, I appreciate the added context there. And Brandon, you've been working at the Graph for quite some time, who's had an interesting evolution around, the sort of the origin stories around the decentralized nature of the protocol. So when you think about data quality from that lens, how has that evolved in your thinking through time? And what were the core challenges around bringing high data quality with that thought of decentralization being at the forefront?
Sure. Yeah. Great question. So, like over time, I guess it's important to give a little bit of context that the Graph about 6 or 7 years ago came out with a really core product called subgraphs. This is an open API that, if you talk to any Web3 developer, they've probably used a subgraph at some point. It's essentially a set of instructions to index a smart contract and get that data into your front end. And it's important, you can go ahead and use that locally, or you can have a provider. It serves you that data, but how do you know that data is actually accurate? It has a quality called determinism, which essentially means that if you put the data in, you put it out, you can have 2 or 3 different providers, compare that, and essentially you can say, in theory, it's you get the same answer basically by consensus. You can say, okay, we have the right data. But the reality is that all that the data that goes in is largely contingent on whether that RPC node or the raw data source is accurate or not. And what we found over time is kind of Web3 developers don't really care so much about whether data is accurate or not. But in theory, this decentralized network can provide you a much more robust consensus mechanism. Now, that said, it's still kind of vulnerable to some of these possibilities of raw data providers, either having overlap or not having the redundancy and diversity that we'd want from blockchain providers. So over time, we've actually kind of seen an evolution in our thinking more away from consensus, more to verification and trying to use the underlying blockchain for some of the verifiability guarantees that we could get from data. So more recently, Edge and Node, who coincidentally develop subgraphs, have developed a new product recently called AMP. And built into this is the potential to verify that blockchain data kind of from the blocks level as well as all the data within these blocks using a cryptographic mechanism. And so from that, you're able to get both verifiability as well as a robust audit trail of that data. So we've kind of moved away from that consensus-based mechanism and determinism towards this verifiability mechanism. It's really amazing to see. And what we expect is enterprise will kind of want to adopt that more for on-prem uses and things of that nature.
Jonathan, anything to add from the indexing side of things around the assurances and the challenges around providing that high quality and high uptime data?
Yeah, no, absolutely. So, so one of the things what we focus on is indexing blockchain data at the lowest level. So indexing, blocks and transactions. And at some point, like the first thing is, in a way, you have to trust the chain to start with. Like you have no choice that the nodes are block producers. They're producing blocks, and so what you can do is use different providers, different RPC providers. You also have the notion of different clients, because we think of like Ethereum as, okay, that's layer 1, and you might think, okay, if I call different providers, I should, in theory, get the same data. But the reality is like sometimes you don't, because there are different clients that are implementing the Ethereum virtual machine, and there are different implementations, and sometimes people have had different interpretations of what the behavior should be. And so we've seen some issues around transfer or what we call traces, where different clients and different implementations of the VM will return a different data set. And so I think what you have to do here is really be cognizant, be as close as possible to the low level, to the lowest layer of the blockchain, to understand how it works and know what to look for, and continuously reconcile across different sources so that you have a a fairly good idea of like how accurate your data set is. And then, it's a colleague of mine that told me a long time when I was joining the blockchain data space, he said that on-chain data is like digging a metro underground line under Rome. You never know what you can find, what you will find next. But you have progressively, you build a muscle memory of how to react to issues and how to test for them. And so progressively, you build an entire data quality harness where like you had more and more tests, you know what to expect, and progressively you build a high quality data set. Now the trick is you will have to learn on that front for every single chain and every single vertical. But then the patterns and the practices to guarantee high fidelity data sets are the same.
I know it's very interesting about the client implementations resulting in different trace sets. That's a fascinating problem. And Mike, on the price delivery side, I think the obvious bit about price data is that it impacts trade execution. So there's a high sensitivity to that. And you touched on the regulatory piece as well. But are there other maybe less obvious challenges when it comes to delivering high quality data on chain as well?
Yeah, I mean, we can't get stuff wrong. This is, as you said, like this is a very specific type of data, so it's not going to be a wide variety. It's the price of something, but very, very high impact. And so we had to design the system to be able to kind of meet those needs. And so basically, there's a couple of different things that you want to kind of pivot around. Number one is there's a minimum number of publishers that you can have. Those publishers only contribute to an aggregate, and then the aggregate is the end result that you have that you publish somewhere on chain. There's a couple of other safety valves in there. One is you want to be able to show the disparity or the disagreement as a vector that's not just the price. Because the worst case scenario is that somebody takes a price that's probably not right and uses it to trade a whole lot there. And so what we did was created a confidence interval. And it allows us to have a slightly more complex aggregation, although pretty simple as well. So every publisher, and think about the network as having, I think we've got 130 different publishers. They're mostly all large institutions, big trading firms from Jane Street, Susquehanna, DRW, a lot of exchanges, Cboe Global Markets, a lot of the crypto exchanges and Binance and so on. So these are all the contributors. And so certain contributors will contribute to different asset classes that they cover or that they trade in. And each one is required to submit 3 values. Well, it's really 2 values, but it gets converted into 3. So it's a price, and then there's a confidence interval. And it looks a lot like a bid-ask, top-of-book bid-ask spread. But basically created a symmetrical version of that. So we take these 3 votes that people have, the mid or the price, plus or minus the confidence interval, and we aggregate those together and we create a weighted median from that to come up with our price. And then we use a statistical distribution, it's a Laplace distribution, to come up with the aggregated confidence intervals. And so that allows you to get a little bit more information. So at any given point, you see what the price is, but you also have a good sense of, well, do these contributors all agree where that's where the price is? And this has helped the network quite a bit during these periods of dislocation, because one thing that tends to happen is exchanges will only know what they have, right? And so that's the problem we kind of talked about for the weekend trading. Like, you have to do a lot of calculus to try and put this together from, do I trust your volume? Do I think you're impactful? Do you think if someone else were to turn on, that volume would still trade there? There's a big benefit to being downstream from trading firms, because a lot of them do this as part of their kind of core competency. And so there's like probably 150-person market data team within a Jane Street, where they're pre-crunching the data based on all the available information, coming up with what they think they can construct fair value on. Before they apply their alpha to it, they basically are able to submit, that they and all of their peers can submit that data to us to be able to contribute to this. So by just having this go through their intelligence process, we actually get a lot of this information for free, as well as then having the exchanges that contribute. So we don't need to go as aggressively into, do we need to construct the volume? Because there's a whole lot of problems. We're talking about data standardization and cleanliness. There's a huge problem with volume, because as anyone who's ever traded before, especially on multiple exchanges, will know, is you don't just add up the volume from the 2 exchanges, because the likelihood is that there's a trader that's showing the same quote on both exchanges. And so you need to figure out like a smarter way to do this. So like the first instinct of what you would have is you take, Coinbase and Binance, you add those volumes together, and then you say, all right, this is what the total volume of the stack looks like, is always wrong. So you have to basically let these people who are kind of constructing these things give you a sense of where those markets are going to be, and it turns out to be really, really helpful. Like, so we've been, so far pretty lucky in terms of when there've been, the 10/10 events or depegging of stable coins. We've been able to see that our price tends to stay on the right side of where actual activity is happening, is because you've got these traders that are kind of actively updating it, and you get that sort of warning signal because one or two of the exchanges that during like the 10/10 event when Binance had the dislocation, then you didn't have other exchanges didn't have it. You basically said, okay, we've got certain outliers here. So as a function of your aggregate for confidence intervals, it shows you something super wide. So it's like something's going crazy in the market. I can show where the price is most likely going to be occurring, but then you can add in other parameters that say, hey, if the confidence interval is too wide, I want to make other decisions. I maybe don't want to let people trade, or I maybe want to remove some of my risk, but it just gives you a little bit more flexibility. But as you said, it is the most important thing, and it is the reason why the protocol needs to be incredibly simplistic to be able to pull data together and publish out something that people can easily interpret.
Yeah, Mike, you also brought up the contributors to the network there as well, which triggered a thought for me, which is, sort of the theme of this conference has been largely the institutionalization of the industry as a whole. So I'm curious for each of us, have we seen your customer set or your contributor set mature or evolve and change in any way over the last couple of years? And I think we all probably have opinions on this. So Brandon, we'll start with you and work our way down.
Sure. Yeah, just to speak to the change in users over time.
Yeah, curious if you'd agree with the idea that with the institutionalization of the industry, has your customer set or those that you're speaking to kind of changed at all? Where maybe in 2020 or 2021 it was like the small crypto native startup as a core customer, versus now maybe it's like, oh, this large bank or this large financial institution or this fintech is interested. Curious if you've seen any of that shift in your contributor network or your customer network as well.
Absolutely, yeah. So maybe 3 to 4 years ago when I started at the Graph, I would say a core product that we have was really serving small to medium-sized developers. At the time, DeFi summer was just kicking off, so there wasn't a ton of power users, I would say, from the perspective of needing indexing. That said, the products that we offered at the time, mainly subgraphs, really did well in serving those users. Those were largely DeFi users, so those DEXs, staking, lending, all those kinds of protocols that are kind of the core of DeFi today. And over time, I think probably the biggest things that we've seen is that those users did really well with those products over time, but as time went on, they really needed to scale up. And the paradigm shift that's really kind of been at the core of what we've been doing is shifting from these APIs to a streaming solution. A lot of users need those streaming solutions largely for two reasons. One, to be able to keep up with the amount of transactions on chain, or to deal with really high TPS or transaction-based chains like Solana and now Arbitrum, BSC, among others. So there's been that shift that need speed and scale, as well as needing that data where they most need it. Typically, in the past, we've needed to host that data for them. That was fine. But we've seen an increasing demand for users needing to stream that data out into their own databases. And that can come in many forms. It could be downloaded as data sets, or it could be a direct stream to get low latency and real in-depth historical data. And if it's just one chain, that's a really important paradigm shift. But when you need 15, 20, 50 different chains, it's a pretty significant undertaking from an infrastructure perspective. And I think probably what that ultimately culminates into is going to be large institutions that essentially need to be able to look at anybody's position at any given time across every chain. And that is kind of what the DTCC is confronting right now. They're a clearinghouse that processes $5 quadrillion worth of assets in a given year. And so they're in this position where they need hundreds of different chains, and they need real understanding of all real world assets across all those chains with 5 seconds after they process on that given chain. So that is a real huge impact and a much different scale than what we initially started out with. I would say that's probably the biggest thing that I'm seeing, and trying to keep up to those trends is, quite a process, especially when it comes to thinking about interoperability and standardization as they relate to that.
Yeah, I mean, we've seen more and more institutions, the more highly regulated ones that have gotten involved. Last year, we published with the Department of Commerce the GDP on over the Pith network onto all the blockchains it's on. We've started to get a lot of banks that are now participating in the network. We'll have more to talk about that in a couple weeks. And we also have gone on beyond providing just cryptographically secured data on chain. And we're actually now selling data to completely non-blockchain companies as well. And so basically, if you think about that as like that two-way street, like we combine everything together using a blockchain solution so that it can solve a blockchain problem. We still have this blockchain solution, but now we can actually solve lots of other problems. And so like the kind of the four big areas for us in terms of focus is blockchain-enabled exchanges. And so last week we announced, we call it Pith Pro X, but it's an exchange product. We're powering, Coinbase just announced that they're doing equity derivatives, so we're behind that. There's BitMEX and Crypto.com and a whole host of other exchanges that are using the data. So that's kind of category number one. Category number two is the new form factor of prediction markets. So that's an area where we're going to start doing a lot more. Category number three is kind of AI-enabled kind of use cases. So we've done a lot of the MCP servers or kind of setting up in the local stores, and we'll have sort of more stuff going on in there as well. And then the last one is institutions. So a lot of institutions that consume data for a variety of reasons, either because they're looking for new inputs to potentially create alpha, or because they're actually looking to lower their market data bill because they don't need as high quality exchange data for middle and back office functions, are now starting to consume the data. So we've totally seen the growth in kind of grown up types of companies that are now buying and accessing our data, and we think that's going to continue.
Yeah, it's really amazing how far we have come, right? If you think about it, right? Like NYC and Nasdaq announced, all these tokenization things. They want to trade 24/7 and be part of the revolution, right? And when I started in 2013, right, we were these borderless hippies believing in one humanity, peer-to-peer transactions, and it's how we started out, right? It was supposed to be a revolution, right? And then 2018, when we launched XYO, it's actually I deleted everything from my LinkedIn account because people who were interacting with me were thinking I was like Pablo Escobar running some other cartel. and it's actually happened, right? Wells Fargo shut down our company bank account, right? And then closed the bank accounts of our employees. And then Capital One did the same. And then we tried to find other bank accounts. It took more than 100 conversations to find another bank, right? And the same happened with insurance and payment processing and all the things, right? And then 2 months ago, and today things change obviously. Like 2 months ago, Coinbase sent us their Coinbase custody bill, and they changed their bank to JP Morgan Chase. It's crazy, right? Jamie Dimon obviously was anti-crypto just a few years ago, and today we are all together in New York, at this conference, and want to make the world a better place. And I think institutionalization obviously happened, right? And it's great. It changes the trajectory a little bit of the original hippie idea, but I think it's going to transform the world, and I'm excited what's coming in the next few years.
So on our side, Duna's been operating for about 8 years now, and so it's been like a long journey, and we've suddenly seen a significant amount of change in how people are consuming the data and what they do with it, and the level of maturity and sophistication has really, really drastically changed. You're going from like a solo data analyst that's analyzing an obscure protocol just as a hobby to selling data sets to like a custodian, for example. And let me tell you that when you think about transfers or balances data sets, a custodian is actually going to go and turn every rock. And if we take the example of Solana, there's like 10 or 12 different types of transfers and transactions, and a custodian has a duty to know exactly how much there is in each account and what comes in and comes out. And so they will use our data set to do a reconciliation process, and they will they will come in and chase us for every single dust, that is missing or like that is extra, plus or minus in a given address. And so I think that the maturity of the different the consumers has definitely changed over the years. It's also, we help a lot of businesses basically like run their on-chain business using data, and so we have like risk creators that are literally running their entire accounting and risk analysis on Dune. And so again, like the level of scrutiny that the data gets is just completely amazing compared to the level of sophistication that there was a couple years ago. And so really excited to be part of that journey. Really excited to like provide the data rails, I would say, for critical infrastructure and critical businesses.
Awesome. And as a closing thought here, maybe if we could each fast forward ourselves to a year from today, we're at DAS 2027, back in New York. What is the one crypto data problem that is a problem today, but will be solved then? Maybe if you could each succinctly describe that problem today and if it will be solved. Brandon, we'll let you start us off here, and we'll work back this way again.
Wow, that's tough. I'd say probably a more coherent standardization, especially at the semantic layer. Like I think it'll be easier to understand kind of like what's available, how to access data, and be able to easily consume that in multiple different ways. But just a clear, more coherent understanding of that semantic layer and be able to tap into that and get it quickly. I think that's probably the most clear thing that pops into mind. Standardization most certainly probably won't be one of them, but I would love to see that. Yeah.
Yeah, for me, I think we'll just continue to see this journey of the 24/7ization of markets that currently operate under like standard market hours, and I think we'll have like a well-worn path on how that happens, and you'll start to see lots and lots of liquid assets start going 24/7. And so I think by this time next year, we're going to be in probably the most liquid competitor of an off-chain kind of incumbent will be in the 5 to 10% area of an on-chain equivalent.
Yeah, I think in 1, maybe 2 or 3 years, all our data problems will be solved, right? Because our agents are just going to standardize the data for us, and it's going to be rawly fed into any system we want.
Well, I'd like to be here to see that. I think that's going to take a while. I think one thing that I think a year from now I really wish we come together on is really thinking about stablecoin. Stablecoin data is really taking a lot of precedence and a lot of importance. And there's a lot of talks around stablecoin volume, stablecoin transactions, and but there's lots that goes into classifying transfers, classifying the stablecoins activity. And I would encourage all of us to be clear on the methodologies that we use. Dune, we recently released the stablecoin data sets and the stablecoin report that we've co-authored with Visa, and we'd encourage you to take a look at all the methodology and all the work that came into tracking USD, but also non-USD part of stablecoin. And so I think what I see now is the activity is rocketing up, the volumes are rocketing up, but the methodology and the scrutiny into the data hasn't really followed yet. And so people are asking the right questions, but we don't have all the right answers yet. And that's something that I think the space will have to continue working on a lot.
All right, we'll be playing this back 1 year from today, and we'll see how accurate we were. Gentlemen, thank you.
Thank you.
Thanks, guys. So that's the state of crypto data. 1 year from today, maybe our agents will be attending DAS in our stead. So let's hear about agents from Cahill, if he's here. Here he is. Cahill's going to talk to us about agents and how they move our money.